So hopefully yesterday, I know some of you guys were confused about the lesson. So I hope you looked at the video again or asked some of your classmates or your friends. But I will actually be doing a proper review for this unit. I'm not just going to throw you guys into the fire by graphing these reciprocal functions. So I'll actually do an actual review where we will actually take up like half the class doing examples together and me asking you guys what steps we have to do to solve or to graph this reciprocal function. Okay, because for some it comes easy, for others it doesn't. I mean, it's just the way we learn. For some people, just rewatching the video was more than enough to help them understand it. It's some of the time people need to see the teacher or another student or their tutor actually do it with them to understand it properly. So, like I said, today you have your quiz after the break. It should take you up until the end of class. So we'll go from 9:50 to like 10:30, 10:40. Again, it's the staple 12 questions. Yes, you're
We're gonna get a test for
we're gonna get a test for unit 3 and 4 combined. Okay, because they're short, and it's a combined like 6-7 lessons, which is the equivalent of 1 unit anyways.
Oh, we're also gonna get a quiz for 4?
For unit 4, yeah, you're gonna get a quiz as well.
Wait, is this unit 4?
No, this is unit 4. The quiz is for unit 3.
Oh, okay.
So the one from the easier unit out of the 2.
Wait, why is it 5? Why is it 5?
Oh, because in the book, we skipped chapter 2, which is rates of change. Because
That's the last unit.
you don't need to learn about that yet because that's like an intro to calc.
Oh,
So we're like a chapter ahead from like the unit. So
Okay.
unit 4 is chapter 5 in the book. Okay. So this is a pretty simple lesson. We're doing the same thing as polynomial equations. It's the same thing when solving rational equations. Okay. So we want to solve the rational equations algebraically and state the restrictions. So for equations, you can cross multiply. Okay. For inequalities, you cannot. So if this was an inequality for A, you would have to bring the 4 over and say 4 over 3 minus 5 minus 4 is greater than or less than 0. Okay? And that lesson will be in the next one. Where is this thing? Here we go. So for 3a, we have 4 over 3x minus 5 is equal to 4. So what we're going to do is we're going to cross multiply. So the 4 is going to stay on the left side is equal to 4 times 3x minus 5. Then all we're going to do is we are going to expand the 4 into the bracket and FOIL. So we're left with 4 is equal to 12x minus 20. Now, of course, you want to leave the variable on one side and bring all the constants to the other side. So we are going to bring the 20 over. So we get 4 plus 20 is equal to 12x, which gives us 24 is equal to 12x. Now to isolate, we just divide both sides by 12. And what is 24 divided by 12? 2. Okay? So this is true when x is equal to 2, okay? But because of the fact that it's a rational function, there are also restrictions. And restrictions are, we need to identify where the denominator is going to equal to 0. And at that x value, we cannot have that happen, okay? So what is our denominator? Okay, so restrictions. So 3x minus 5, remember, we cannot have the denominator equal 0, okay? So all we're going to do is just isolate for 3x. So you get 3x cannot equal 5, divide both sides by 3, x cannot equal 5 over 3. So what happens at the point when x is equal to 5 over 3 on this graph? Doesn't exist. Because it's not defined, right? Because if we sub in 5 over 3 for the denominator, it's going to give us 0. And 4 over 0, as we know, gives us a error or undefined answer in our calculator. So
you lost me. I'm being serious.
On what part?
What's it called? Like, why'd you have to do the whole like switching it to the other side for the restriction?
because we cannot have the expression equal to 0. Okay? So we cannot have this denominator equal to 0, which is why we set it not equal to 0.
So like, for example, if it's like 4, like every time we gotta do it not equal to 0?
For the denominator only.
Okay.
Okay,
like,
so for this one, so for this example, after we factor out, we just do the factors. So let's just say it's x plus 2 times x minus 1 cannot equal 0.
And it will only be for this side, not the other side? Or do we do both sides?
It depends. So for here, we have 2 denominators, so we would have to do it for both,
Oh,
because
okay.
both of them can't equal 0.
So it's whenever there's a denominator?
Yep.
Okay.
Is everyone fine with the first example? So the next one we have is x minus 5 divided by x squared minus 3x minus 4 is equal to 3x plus 2 divided by x squared minus 1. So what we want to do first, what do you want to do with these trinomials and this?
Fact.
Yeah. So what's the easiest one to factor?
First one.
Second one, what does the second one look like? Difference of squares. So we get 3x plus 2. And what does x squared minus 1 factor into as a difference of squares? Yep. And then we're left with x minus 5. And now we have to factor out this trinomial, x squared minus 3x minus 4.
X plus 1, x minus 4.
For which one?
Yeah.
What'd you say?
X plus 1, x minus 4.
X plus 1, x minus 4. Thank you. And if you didn't get why Yusuf said that, our product here is -4, and our sum is -3. So we need 2 numbers that multiply to -4 and add up to -3. So he said -4 and 1. So that gives us -4. And -4 plus 1 gives us -3. So, what would we have to do next? We're going to cross multiply. So we get x minus 5 times x plus 1 times x minus 1 is equal to 3x plus 2 times x minus x plus 1 and x minus 4.
Wait, sir. Like, this is the only thing I remember from grade 11. And don't we have to, like do restriction, like, for every step?
Well, you can do the restrictions at the beginning, so we can just look at the denominators right away.
Yeah, that's what I was
Okay.
saying.
So we can identify our restrictions first, that way you don't forget it at the end. So what would our restrictions be for example B? X cannot equal? X cannot equal -1, 4, and 1. So that would be our restrictions.
So, like, we can also do it at the end, right?
Yeah, it doesn't matter. So let's just take it a step back. So because we cross multiplied this, so if this comes to the numerator, what can cancel out? What do these two have in common? X plus 1. So they can just forget about each other.
Wait, sorry. How?
So because we're cross multiplying,
Right.
so once this comes here, you're gonna have an x
Oh,
plus
right.
1 at the top anyways, so you can just cancel them out. And same here, you bring this over, you have x plus 1, cancel those out. Yes, Adam, we canceled out the x plus 1. So what we're left with is just x minus 5 times x minus 1 is equal to 3x plus 2 times x minus 4. And now all that's left to do is to FOIL. So we got x squared minus 6x plus 5 is equal to 3x squared minus 12x plus 2x minus 8. So again, we just have to simplify the like terms together. So we get x squared minus 6x plus 5 is equal to 3x squared minus 10x minus 8. And now what would be our last step? You have to set the equation all equal to 0. So we get 0. So we're going to move the left side over to the right side. So equal to 3x squared minus x minus 10x plus 6x minus 8 minus 5. So when we simplify that expression, what are we left with?
2x squared minus 4x minus 3.
Not minus 3. Negative 8 minus 5.
Oh, it's minus 5?
Yeah.
Oh, minus whatever.
Minus 13. If you guys don't know what the answer is, just put minus whatever on the test.
Are you gonna give us a mark?
I once gave a kid, because the kid was doing so bad in my class one time, I once gave him like 2 marks for drawing something cool. He actually drew something, I was like, this is actually pretty cool. So I gave him 2 marks.
Wait, sir, does it matter where you put the 0? Like, if the 0 is on the left side of
But I would prefer, this is the thing, would you rather this be positive or negative?
Right.
X squared.
Also, because like I was doing the whole like the practice for the last unit, like it just confused me because it expected us to have the variables on the left side or something as opposed to the right. So
I mean, you can do that, but then you would just have to factor out the negative
which
one.
makes it even more tedious.
Yeah.
Okay.
So I like keeping it to where the highest degree is positive, so that it's easier to work with. Especially with factoring and synthetic division, it just makes it easier. So now we have to check if we can factor this polynomial or this trinomial. So can we? What would our summing product be for that trinomial over here? Yep, and our sum. Are there 2 numbers that can possibly multiply the negative 26 and add up to negative 4?
I mean, like, there's decimal, no?
So if they're decimals, Yusuf, what formula do we need to use?
The P and F, Q, whatever.
Not P and F, Q, quadratic formula. So the easiest way to do the quadratic formula for me, hopefully it is for you guys, is to just find the discriminant first. Don't actually write the whole formula out. Find the discriminant first, and then just sub in your values after. So let's find our discriminant. So we have b squared minus 4ac. So we got negative 4 squared minus 4 times 2 minus 13. What does that give us for our discriminant?
Negative.
Pardon?
Negative 8.
Shouldn't give us negative.
Wait, hold on.
Because we have a negative here,
Okay.
a negative here.
Yeah. Oh, I don't know.
It's not 16. It's number 12. Oh, yeah. He's doing it in his head. Let's see if he can get it faster than Jose.
Yeah, I'll give you a head start, Tim, sir. Oh,
120.
Oh, thank you. You just forgot it. So equals 120. Okay. So now we sub it into our quadratic equation. So we get x is equal to negative b. But because b is already negative, it turns into a positive. So we get 4 plus minus the square root. We did a discriminant of 120 divided by, what's 2 times a?
4.
4. So now our roots are going to be x plus 4 plus root 20 divided by 4, or x minus root 20 divided by 4.
3.7.
So what's our first x value?
3.7.
And what's our next one?
Negative 1.73.
Negative 1.73.
Yeah.
So you can write this two ways. You can write it the lazy way with the decimals. So you can write it as 0 is equal to x minus 3.7 times x plus 1.73. Or you can write it as 0 is equal to x plus 4 plus root 120 over 4 times x plus 4 minus root 120 over 4.
Yeah, I'll stick with it.
So that like second part, we have to like write 4, or like is it just like a bracket?
This one?
Yeah, like how do you set that up?
Oh, so you have the negative. Oh, as I didn't have room. I didn't want to cover this question. It'd be beside it.
Okay.
Usually.
I like significant figures like a thing in math, but we have to like,
That's only in physics.
Why?
cause like, so like we just put like however many decimals we want, or like decimal places.
Well, it's usually generally for math it's always the nearest tenth or like 100th. So I don't think you've been asked what a 1,000th is since like grade 6.
But why? What's the purpose of sig figs anyway? Like
It's important when it comes to currencies. So for example, if you want to exchange your Canadian bills for like American or Euro
either you
bills,
round up or you round down.
I think they have it up to like the 100,000th. So they have like 6 decimals when it comes to that. But it all depends on what you're using those decimals for. Okay. Nearest tenth. Well, so let's give an example. What does gas usually go to? Like what decimal place?
To
100,000.
Tenth. It goes to the tenth. You got 99
What's
points.
Costco?
No.
Oh, that. Oh, you okay.
Yeah.
Then yes.
Let's see. How about?
It's not 0 point something.
Oh well, yeah. It usually depends on the gas meter. Some just say 99.9, so like 99.9 cents. So they have the tenth, but some say 0.999.
Yeah.
So it goes to
okay.
thousandth. But for money, we go what decimal place do we round money to?
100.
Yeah.
Wait,
So it all depends. It all depends on what you're using it for. So in math, I have a bad thing where I don't specify what decimal, so I'll just always assume 100th.
Wait. We're allowed to use decimals.
Oh no. I mean, I would prefer you not, but I half the time I don't give you things that are factorable that give you decimals. They're always going to give you full numbers.
Wait, sir, for the test, why did you give us such big numbers, man?
Oh, the
Which one?
100,000.
Yeah, like, It wouldn't even switch to. It wouldn't even
Oh,
switch
the
to
thing where it's like prove this has no real roots?
Yeah,
Wait, hold on, let me
no,
pull it
no, the very last question.
Oh, the one that had like 3,000?
3,000 something.
Yeah, it was
Oh,
like
yeah.
3,000.
Make the graph thing,
Make
right?
the
Was
graph.
its local max was like 3,136.
Yeah, I was like, what happened to the small
I honestly thought I made a mistake.
I thought I made a mistake just like Sir said it's gonna be really easy.
It was really easy. What number was it? Like -1 you subbed there and gave you -3,000?
No, but
Negative-
there was
negative-
another local something, and then it was like 1,000 something.
Oh, that was the other one on the right side, I believe.
Yeah, that was 2.5? 2.5, 1,080.
Yeah, something like that.
Yeah. I was tripping me up because I was like, he said it would.
It wasn't just.
I mean, were the x values big? No.
Yeah, I know.
It just because of the exponents, that's why it gave you such a high y value.
Oh.
So the more weird things you have happening in a polynomial function when it's factors, so like, let's just say you have like a 3 and then a 4, the higher your values are going to be when it comes to like the maxes and mins. Okay. So let's do example C. So we have 1 minus x minus 1 over 45 is equal to 1 over 2x minus 3. So before we cross multiply, what do we have to do with the left side first?
Restrictions.
So we'll do restrictions first, and then we have to find common denominator. Sorry. So what are our restrictions for this? X cannot equal
0 and 3 over 2.
3 over 2.
Wait, why not 45?
Because 45 is just constant.
Wait, what?
It's by itself. Like 45 doesn't have a variable. So the restrictions don't count towards constants that don't have variables. So like if it was 60, doesn't matter. It's
Oh,
not a
okay, okay.
restriction.
As long as it has like an X or something.
Yeah.
Because you don't want your denominator to equal 0, right?
Because then you're gonna get some error on the graph, or as you know, it's just gonna be an asymptote in the reciprocal function. So before we cross multiply, what do we have to do with 1 over x and 1 over 45? No, it's just two fractions being
Common
subtracted.
denominator.
Yeah, common denominator.
Oh, that's
So-
good.
When it comes to polynomial and like anything with a variable, the common denominator is just the two denominators being multiplied together. Okay? I know that's what they told you not to do in elementary school with the numbers. They're like, oh, don't just say it's 3 times 12 and that's your, or 3 times 4 and that's your common denominator. So what we're gonna do is, so the denominator is gonna be combined, so it's gonna be 45 times x. So what is missing from 1 that we have to multiply it by?
45.
45. So you get 45 minus x is equal to 1 over 2x minus 3.
Wait, so now would it be a restriction?
It's still 0, and it's still 3 over 2.
No, but 45 is attached to the X.
Yeah, and it's still 0.
Um,
It doesn't change. So what's 45 times 0, Yusuf?
No, sir, that's not what I'm saying, because you know how, wait, what? No, because like anything attached to an X is always 0. Oh, okay.
So even though we attach the 45 to the x, our restriction is still x cannot equal 0.
The restriction will just remain constant even for
Yeah.
the first claims, yeah.
Even if you had two factors as a denominator, so say if you had x minus 3 over here and x minus 4 on the other one, it's still going to be x cannot equal 3 or 4. Even if you combine them together, it's still x cannot equal 3 or 4.
Oh, okay.
So our next step is going to be cross multiply, like we did before. So you get 45 minus x times 2x minus 3 is equal to 1 times 45x.
So I think my brain isn't working. Why is how'd you do the minus x up there?
Okay, so let me just break it down. So because our common denominator is 45 times x, okay, the denominator in the first fraction already has x, right? But what's missing from it?
Like 45.
45. So you do 1 times 45 minus, and the second fraction has 45 as its denominator. What's it missing?
Oh,
An x.
Okay, I got it now.
So you get 1 times x. So it's just 45 minus x.
Makes sense.
Yeah, whatever you do to the bottom, do to the top.
So now we're going to FOIL our expression.
45 times,
So you get 90x minus
135.
135 minus 2x squared plus 3x is equal to 45 minus x. So we're going to bring everything over to once. Yes.
Then you put the 45x,
Yeah.
not 45 minus x.
No, the other side,
Oh, whoops. Thank you. So now, remember, it's easier for the highest degree to be positive. So which side are we going to move these things over to?
Right.
Okay. So we're gonna get 0 is equal to 2x squared plus 45x minus 90x minus 3x plus 135. And when we simplify our like terms, what do we get? What's 45 minus 90 minus 3? Negative 48x plus 135 is equal to 0. So again, we want to try to factor. So what's our product? What's A times C? 270. And what is our sum? So is it possible to have two numbers to multiply to positive 270 and add up to negative 48?
Find out.
No,
No.
Really?
that's not a decimal.
So with big numbers, just use quadratic right away. There's really no point in trying to get, unless it's easy, unless it's like a multiple of 10, then it would be easy to work with, or like a multiple of 5. But
You won't ever ask us like you won't ever make us do a question where the number's big and we just have to factor using someone.
I'm gonna say just factor using sum and product for 10,480 with a sum of negative 60.
Thank you. I considered it.
That would take you a lot. I would just give up at that point. Like,
I would just search up the factors and then try them all out.
I mean, that's true, but we'll see. Okay, so we're going to use our quadratic formula. So let's start with our discriminant first. So we got b squared minus 4ac. So our b squared is negative 48 squared minus 4 times 2 times 135. So what does our discriminant simplify to? 3,000? 300? And what?
I got 1,224.
I don't think.
Am I doing something wrong?
Yeah, 2,380.
Negative 48 squared minus 4. I got 1,224.
All right.
What did you get? Let's see. Let's just use an example of
You
data.
got 3,000. 3,084.
Not 84. Got,
Yeah,
how would you get all the
2304.
Oh yeah. I'm getting different. Hey Siri.
1,224.
Yeah, I was
That's
right.
what I got.
Well, what do you?
I got yours at first.
Did you make one of these negative by accident or no?
Oh, like the total. Oh, I was. I'm
Oh. Yeah, the 135 was negative.
Yeah, the 135 turned positive when we brought it over.
Yeah, I remember that.
So 1,224.
Like,
You got scared?
just like, hold up, glitch. One.
Just trying to see if it has a perfect. Okay, there we go. So can we simplify this root?
Good question. Nope. Oh, well, it's gonna be a decimal.
Well, so if we do 9 times 136, it gives us 1,224. Okay, so we get root 9 times root. Yes, we're simplifying radicals now.
Wait, root 9?
If we forget to do this and just like give a decimal, is that like minus marks?
9.
I mean, I would have to specifically state that leave it in like exact root means leave it in radical form. Okay. So what's the square root of 9?
That's the root.
Okay. Can 136 be divided by a number with a perfect square root?
Oh,
Probably 6.
Nope.
7. Oh, is that right? 4. Oh,
4.
4.
that's close.
So
Oh, yeah.
this can also be divided by 4, so we can simplify it even further. So we get 3 times root 4. And what's 136 divided by 4?
34.
34. And that simplifies to 6 root 34.
Wait, hold, oh,
Eight?
right.
Nope.
Nope, there's nothing. This is it. This is it.
Is it? Okay.
This is it.
Gotta be thorough.
Okay, so we can either get x is equal to negative 48, so our b, which is already positive, negative, so it gets 48, plus or minus 6 root 34 divided by 4. So at what x values do we get our function equal to 0? So remember, we have to do 48 plus 6 root 34 and 48 minus 6 root 34, and all divided by 4.
7 and then 48 minus 6. 4. You get 39 and 22? Oh, that's right.
3.25.
You're going to 5?
Hold up, I know where is it wrong.
Yeah.
Yeah. Yeah.
For calculating, like, can we like go for radicals like in our calculator? Like, how do you do that?
Oh, radicals in your calculator? Like all in one shot?
Yeah.
What type of calculator do you have?
Hey, seen these.
You can do it, right, Jose?
Yeah, I have to get the answer of like the top, the numerator, and then divide it.
Yeah, that's what. So you would calculate the top half first, because sometimes calculators are dumb, because they would just.
Like, how do you put like the 6, like,
Oh, you
Oh,
do
6 root 6. So it'd be 6
bracket
34 or something like that.
cause like when I press like enter, it was like.
Like, wait, do you do that too?
If I just do this.
It'd be 34.9, right? 6 root 34 would be 34.9.
Is that correct?
I would say, sir.
Okay, so you have to do like brackets.
Yep, and then you get 82.9.
Oh.
Divided by 4. You do the first one.
I don't put brackets.
I just do this.
I just use whatever.
Holy, I don't do that.
I don't know about you guys, but the quadratic formula gives me a headache. I'd rather have numbers that I can actually factor.
So, okay, are you gonna be lenient and give us numbers? that we can
I
back?
might give you just one quadratic formula question, just because, to
Right.
see if you guys remember. And that's probably it.
Thank you.
I think in one of my tests last year in night school, there was a unit that had nothing to do with factoring, but you had to use quadratic formula, and they forgot to use the quadratic formula, so they
Because
all
that
got the
wasn't-
question wrong.
Oh,
Hey, but you're supposed to bring on the knowledge from grade 11 into grade 12.
we also need to remember.
When to use it.
Oh, that's right there.
What's gonna be? What's next?
Hold up.
So we're gonna move on to the next example. So
It's just a lifetime, and like you do like a circle, press the middle and everything.
I'll write that, I know.
Try it. I want to this.
It's really tough.
No.
Next for the space.
There you go. Very clean, very healthy.
But then if you miss everything on the circle on the outside, then you have to go wipe it again.
Yeah, but at least it.
That's true. So our next example, we have d is equal to x minus 2 over x minus 4 is equal to 0. So let's start with our restrictions. What are our restrictions?
X cannot be positive 4.
X cannot be 4.
Frozen.
Okay. And let's see if we have what's it called, an X-intercept. So that means y has to be equal to 0. Okay, it's already equal to 0 anyways. So these would just cancel out. So we're left with x minus 2 is equal to 0. Move the 2 over.
X equals 2.
Yep, so our X-intercept is at 2 and 0. So we're going to draw our axis. Is the denominator the vertical or horizontal asymptote? The denominator, does that represent the vertical or horizontal asymptote?
The
Vertical. Let's see, I'm trying to test you guys from yesterday.
Oh, but is there
Do we have a horizontal asymptote?
yeah, is it at one?
It's at 1 because x and x have the same degree and the numbers in front of them are just an imaginary 1. So our horizontal asymptote is at y is equal to 1.
Wait, hold up, sir. I'm gonna lie you.
With the horizontal asymptote?
Yeah.
Okay, so you see how we have
Like what?
you see how we have x minus 2 and x minus 4?
Okay.
What is the degree of the x's in both the numerator and the denominator? 1, right? So if they both have the same degree, there's a horizontal asymptote. All you're doing is dividing the constant that's attached to the x in the numerator.
Oh, that ratio?
Yeah.
Oh, okay.
So it's 1 divided by 1, which is just,
One, and then that's where the line.
that's where your horizontal asymptote is. So we have a x-intercept at 2 and 0. So our graph would look like this. And on the other side, it would look like this.
So like, you can't really know what it's gonna look like on these other both sides.
That's why I said yesterday, look at the behaviors approaching the vertical asymptote. Remember that, like, as x approaches like 4 from the right,
Oh, that.
you take a number that's to the right. Yep.
Okay.
You take a number that's to the right of 4, and then calculate it. That's what you would do to help you draw that out. Okay, so is everyone good with the equations? Easy cross multiplication, factor, and then solve for your x's. Oh, look, so we have a question that you were complaining about yesterday. It's the exact same concept.
Okay,
So apparently there was a question in the, if you guys got the course package, there's a question that stated that if someone had worked, took twice as long, the solution said it was x over 2, right?
Yeah.
It should have been 1 over 2x because they're taking twice as long.
Wait, in this thing?
Is it 2x?
Wait, where in this thing?
No, it
But
was,
because we're using rationals, we put it as 1 over 2x.
it was almost correct, it's an extra practice you put.
On one day, this is gonna fall on my foot. Okay, so we have when they work together, Stuart and Lucy can deliver flyers to all homes in their neighborhood in 42 minutes. When Lucy works alone, she can finish the deliveries in 13 minutes less time than Stuart when he works alone. When Stuart works alone, how long does he take to deliver the flyers?
X plus y equals 40.
X minus 13.
Oh, so what's Lucy's expression?
X minus 13.
Let Lucy equal.
But because we're dealing with rationals, what would our numerator be?
1.
1 over x minus 13.
Why is it irrational?
Because there's gonna have to be restrictions where they don't actually meet. Let me just see.
How do you know that, like, before you do that?
At the end of the day, honestly, you can probably just write this as a regular m minus 13. I think I can probably show it to you guys where it's, if you can do it as not irrational and it'll still give you the same answer. Because all you're doing is, because the numerators are all 1, you're just really just cross multiplying everything and it's gonna give you the same thing back. So if Lucy is 1 over x minus 13, what is Stuart?
Wait, sir. Don't we also have to define what X is?
Did you see that?
Yeah, we can say, what do you want x to be?
I don't know what X is, that's why.
Time.
Time?
Because it's asking how long. So we're assuming the variable is corresponding to time.
Oh, okay, okay.
So we're gonna say let x represent time. So if Lucy is 1 over x minus 13, what is Stuart? Do we have any conditions on Stuart? Is he slower, faster, or is he just the reference point?
It's just a reference point.
So it'll just be 1 over x. Okay? And the question also says, when Lucy and Stuart work together,
42.
how long does it take them to 42?
So you add them.
Yeah.
Yep, so the expression from Lucy plus the expression from Stuart gives you 1 over 42.
Wait, what?
Because
Oh, right.
Because we don't know time, but we do know that together they do 42. Makes sense.
So what do we have to do with the left side of the expression first?
Common denominators.
So common denominators. So our denominator is going to be x minus 13 times x is equal to 1 over 42. So what do we have to multiply the first fraction by to satisfy our denominator? X. Plus x minus 13.
Nice.
So when we simplify, we get 2x.
2?
Yep.
Oh,
X plus x minus 13 is equal to x minus 13 times x is equal to 1 over 42. But before we get into it any further, let's state our restrictions first. So what would our restrictions be for this example?
13 and 0.
Yep.
Wait, sir, I'm still lost. Why is it rationals?
Why are there rationals?
Like, how would you, like, where in the question did it show, like, you have to do rationals? Like, I'm guessing, yeah, because it's in a unit, yeah, you gotta do that, but like,
I'm just trying to read the question to figure that out. Hold on. I mean, unless you assume that they want the answer that the 1 is in hours and they want to convert it back into hours, then you can use the rational. But other than that, we're going to try to use it without after and see if we get the same answer. Okay?
wait, is this not the rational?
Yeah, this is a rational. But I'm saying we're going to try to do it without it. So for example, we know how we said 1 over x minus 13. We're just going to use x minus 13 plus x is equal to 42 and see if it gives us the same thing, which I'm sure it will.
Yeah, that's what I was thinking.
We can't like cross out x minus 13 because it's like times and it's plus.
Yeah.
What if it's like both plus? Like, when does it work?
Which one?
Like row like in front of that, above it. Like,
So
it's, like,
you
adding.
can't cancel out. You can only cancel if the same thing is happening in the numerator and the denominator. So if these were being multiplied together, then yeah, you can cancel out. But because there's that addition, you can't cancel it out because you're left with this expression. Even though if you factor it out, you still get the same
What if
thing.
it was like the bottom one was like added instead? Does it work?
This one?
Yeah.
X plus 13. Yeah, because then you just get the same answer.
Okay, so you can
Yeah.
do it like no matter what as long as.
So we get 2x minus 13 over x minus 13 times x equal to 1 over 42. And now all we're going to do is cross multiply. So we get 42 times 2x minus 13 is equal to x minus 13 times x. So we're going to FOIL in our 42 into the bracket. So we get, what is it, 84x? Minus, what's 42 times 13? 546 is equal to x squared minus 13x. So we're going to move things over So we're gonna leave the x squared positive, so we get 0 is equal to x squared minus 13x minus 84x minus 546. So what does that simplify into?
X squared minus 97x plus 546 divided by 3.
So there is a factor that does help this out.
97x.
Sorry, oops.
Oh, oh. Just next to
6 and 91.
6 and 91. Yep. So you got 0 is equal to x minus 6.
Trial and error.
Or also because I'm built different.
Times x minus 91. So at what times does it take Stuart to deliver the flyers? So one of them is going to be inadmissible, and one of them is going to be our actual answer.
Right, because time can't be negative.
So which one gives us a negative time? So let's sub in 6 into Lucy. So we get x minus 13 for Lucy, which is equal to 6 minus 13, which gives us negative 7, let's just say minutes. And can we ever have negative time?
No, not yet.
So this is called inadmissible. So therefore, what does our answer have to be? 91.
Dang, Lucy beat Stewart so bad.
Yep.
This is just my fiction. Bruh. Like, it's an hour and 31. Is that? That's an hour and 31 minutes, bro. Stuart, you're slacking. Come on. So funny though.
Maybe Stuart's just enjoying life, you know?
Who enjoys their job?
What?
Well, Jose, way to make me feel bad.
Oh no, I meant like in terms of my
Right.
You
What
know,
are you gonna do when you get your first job? Just start complaining?
I already at work.
The way you complain.
I think you're after the job.
Oh, probably not actually.
I mean, if you like it.
Oh,
But you just said no one
Do you
like.
think that like even like pharmacy?
Cohort A
honestly,
and C, do you guys have any questions, or are you guys good?
honestly, yeah. I mean, helping people.
Like, I mean, sure, sometimes like.
It'll be tedious or something because it's repetitive, but at the same time, the satisfaction of helping someone.
Like, was there a different, is it, would it be pharmaceutical person?
Yes, that's why I want to go into pharmacy.
Juliana, I'll give you your answer as to why we're doing as to why this is irrational later, because
Yeah.
I don't want to give you a terrible answer because I don't have a good enough explanation in my head right now.
Oh,
That's why
is it because like,
All engineering. That's what we work on.
does it build off the next lesson?
No, it's just because if you do it just regularly, you got 2x minus 13 is equal to 42. Yeah, 2x is equal to 55. You divide those by 2, you get 27 and a half. So let me just read this question. Let me just read the question on my spare time and just justify
Yes.
why it's irrational. So we have our last example. I think we're only going to do one lesson today. I want you guys to study.
Thank you, sir.
So we have salt water is flowing into a large tank that contains pure water. The concentration of the salt, C in the tank at T minutes is given by C of T is equal to 10T over 25 plus T, where C is measured in grams per liter. When does the salt concentration in the tank reach 3.75 grams per liter? Sounds like a chemistry question. If you had a graphing calculator, how would you check your answer? So what are we going to sub in for C of T? Remember, C is the concentration of salt over
I can,
Is this even says like 0 or something?
concentration is in.
Don't we just look in,
Remember, C is measured in grams per liter.
don't we just look in 3.7?
Yep. So 3.75.
Oh, I thought you meant like something for T, and I was like,
No,
oh, my bad.
Why would you do that?
I overthink.
Okay, so what's our next step? We're going to cross multiply. So we got 3.75 times 25 plus T is equal to 10T. So we're going to FOIL the 3.75 into the bracket. So we're left with 93.75 plus 3.75 T is equal to 10T. So all we have to do is keep the variable on one side and keep the constant. So we're just going to leave the constant 93.75 on the left side. So we get 93.75 is equal to 10T minus 3.75T, which gives us 93.75 is equal to 6.25T. And how do we isolate for T?
Both sides.
We're going to divide by 6.25. And then we get T is equal to 15.
So the only reason why we didn't bring the constant to the other side of the variables is because we need to determine what T
Yeah.
is.
That's it. So guys, how would you use your graphing calculator to check?
I don't have a graphing calculator.
Okay, how would you use Desmos to check?
Oh,
Just plug it in.
Just plug in the whole equation and look for 3.75 and that's your answer right there. And yes, we don't have that. I don't even think this department has a graphing calculator.
Wait,
I thought we can't use that.
what's the graphing calculator?
Oh, you remember those things in grade 9 that the bulky big screen calculators? Oh, they never did
They
you hear?
never even gives anything.
I think those weren't allowed. Like if someone had a graphing calculator, you could use that during a test or something.
Cheat, yeah. Yeah, no, there was, it's a big, it's like this long, with like a screen this big. Yeah, you
Oh,
just
it just
input
graphs it
points.
for you?
Yeah,
Why is
but
that?
it gives you in like a pixely graph, so you can't even,
Oh.
it's terrible. It's not even worth it. Okay, so you guys have about 20 minutes to study for your quiz. We'll start our quiz at 9:50, which is after the break. So just stay logged on in the call, and then you guys can log off after your quiz is done.
Why are you hitting me? Oh, you still hit me.